Welcome to Enhance Your UI Animations and Transitions, where I'm happy to tell you your SwiftUI, UIKit, and AppKit animations are friendlier with each other than ever. And to celebrate that friendship, I've made some friendship bracelets. And it's through the power of that friendship that I have some awesome new features and APIs to share with you today. So if you'd like to learn how to add a cool new fluid zoom transition to your app, where a cell you tap zooms in to fill the screen, or use SwiftUI animations to build a fluid interaction, even with UIKit or AppKit views, this talk is for you. Note all the animations in this video are slowed down to half speed. To showcase these APIs, I made this app to plan my friendship bracelet designs. Each one encodes an API I love with the first letter of each word in the API. This one stands for SwiftUI.animation.spring.repeat forever. Now let's get into the details of what makes this friendship so strong. First, we'll talk about some new high-level transitions for navigation and presentations. Next, we'll go lower and learn about some new integration between SwiftUI animations and UIKit and AppKit, which help power these new transitions. Then, we'll talk about how to bridge SwiftUI animations through representable types and mixed hierarchies. And finally, we'll talk about how animating UI views and NS views is extra powerful when continuous gestures are involved. Let's get into the new transitions. In iOS 18, there's a new zoom transition. With this new transition, the cell you tap morphs into the incoming view. And it's not just a new visual appearance. It is also continuously interactive, allowing you to grab and drag it around from the beginning or during the transition. In parts of your app where you transition from a large cell, the zoom transition can increase the sense of continuity in your app by keeping the same UI elements on screen across the transition. Let's adopt it in code. Here's some existing code I have for a navigation link that shows a preview of a bracelet, and when tapped, pushes into the full bracelet editor. This code results in the default slide transition, where the incoming view slides in from the trailing edge. But this is a perfect situation to use a zoom transition. To opt into the zoom transition, there are two things we have to do. First, we say that we want it. This means adding the navigation transition style modifier to the presented view and specifying the zoom transition. Second, we connect this modifier to a source view so that the system knows which view to zoom from. In both places, we specify the same identifier and namespace so that SwiftUI knows which preview goes with which presented view. And now, we're zooming. To adopt this zoom transition with UIKit, the story is similar. Here, I have some code where, when a bracelet preview is tapped, I create an editor for that bracelet and push it onto the current navigation controller. To adopt zoom here, first specify on the pushed view controller that it would like to zoom, and second, provide the view to use as a source of the zoom transition. It works! Note the closure passed to the zoom transition will be run on zoom in and again on zoom out, and it should capture a stable identifier, in this case the bracelet model object, that can be used to fetch a view rather than capture a view directly. This is important in cases where the source view may get reused, such as in a collection view. Now I can also swipe between bracelets without leaving the editor, which means the editor's bracelet can change. To handle this and zoom down to the correct bracelet preview, use the context passed into the closure to retrieve the current bracelet from the editor. And by the way, these same APIs work with the full screen cover and sheet presentation APIs in both SwiftUI and UIKit. Now for UIKit apps, we're going to go more in depth for a minute and go through how these new fluid transitions work with view controller lifecycle and appearance callbacks. For my SwiftUI friends, you'll learn a little about what we do with callbacks in UIKit. Throughout this example, we'll consider the state of the bracelet editor view controller being pushed on. And first, I'm going to go through all the cases that show how the system already works. The red dot represents the current state of the editor, and as it moves by a callback, the method is called. In the normal case, if a push runs to completion with no user interaction, the editor starts in the disappeared state. Then moves through appearing during the transition, calling view will appear, is appearing, and did appear, and ends in the appeared state when the transition finishes. Similarly, if a pop runs to completion, the editor moves through the disappearing state during the transition, and then ends back in the disappeared state. This is true whether the pop was initiated from tapping the back button or an interactive swipe. Now rewind, because I want to review how the canceled pop works as well. If I only drag a little and hold, the editor moves to the disappearing state when the pop transition starts. Then if I lift my finger such that the pop is canceled, the animation runs to completion. But then at the end, the view controller moves straight to the appearing state. And finally, the appeared state in one turn of the run loop. Okay, so that covers callback timings in the existing transition scenarios. Now I'll show what happens when you really test the fluidity of these new transitions. We'll go back to the beginning with the editor in the disappeared state. I start a push, and now the editor is appearing. Now let's consider what happens if I start a pop in the middle of the push, either by tapping the back button or with a back swipe. In this case, the push is not canceled. Instead, the push completes immediately, so the editor goes straight to the appeared state. And then in the same turn of the run loop, the pop transition starts, moving to the disappearing state. And then from here, it's a normal pop transition, which may complete or be canceled. Canceling a push is different from how canceling a pop works, and this is on purpose. Conceptually, the system never cancels an interrupted push. Instead, the push is always converted into a pop. From the perspective of the push view controller, it will always reach the appeared state, which means the system always runs through the full cycle of callbacks, just as it always has. Phew! I think I need another friendship bracelet to remind me that appearance callbacks really are my friend. This new feature is as compatible with existing code as possible. I have some additional tips for UIKit apps to ensure your code works perfectly in this new world where push and pop transitions can begin at any time. Be ready for a new transition to start at any time. Don't try to handle being in a transition differently from not being in a transition. Here, the tap handler fails to call push if a transition is in progress. Just call push, regardless of whether a transition is running or not. Keep temporary transition state to a minimum. The less state you have, the less likely you are to make other code dependent on transition state, and it's one less thing to clean up. But if you do need to keep track of state during a transition, reset it by view did appear or view did disappear. These are guaranteed to be called at the end of the transition. If you're using the navigation controller delegate methods will and did show view controller, the same is true for those as well. And finally, incorporate SwiftUI into your app. Being more functional than imperative, SwiftUI is generally better equipped to handle a continuously changing world. Now, helping to power these new transitions are some amazing new lower-level APIs for animating UIKit and AppKit views with SwiftUI animations. Let's check out how to use them to build some custom UI. Here's my bracelet editor, and I can tap a bead in the box at the bottom to add it to the end of my bracelet. If this UI was implemented with UIKit or AppKit, we would use the existing animation API, describing the spring in the parameters of the call, and then updating view properties in the closure. For SwiftUI, there's a similar syntax where we describe the animation with a SwiftUI animation type and update state in the closure. But wouldn't it be awesome if you could have the best of both? Now in iOS 18, you can. You can use a SwiftUI animation type to animate UIKit and AppKit views. This lets you use the full suite of SwiftUI animation types, including SwiftUI custom animations, to animate UIKit views. If your code works with CA layers, there are a couple of implications to consider when using this new API. The existing UIKit API generates a CA animation, which is then added to the views layer. However, the SwiftUI animation does not create a CA animation, but instead animates the views layer's presentation values directly. These presentation values are still reflected in the presentation layer. Now that we've talked about how to animate UIKit and AppKit views, let's talk about how to animate them in the context of representable types, like UIViewRepresentable. I have an existing UI view for my box of beads called BeadBox, and I'm embedding it in my SwiftUI app with this representable wrapper. it has a lid that I can open or close with this is-open binding. Right now, the lid just appears and disappears when I open and close the box, but I'd love to animate it. The natural way to do this, without knowing whether Beadbox Wrapper is implemented with UIKit or not, is to add an animated modifier to the binding. And if Beadbox Wrapper was implemented with SwiftUI, this would work. But because Beadbox Wrapper is implemented with UIKit under the lid, we need to bridge the animation ourselves. Here, I've used the new animate method on the context, which lets me apply any animation on the transaction associated with this update to any UIView changes I make in the update UIView method. It grabs whatever SwiftUI animation is present on the transaction and bridges to the UIView animate method to slide the lid up or down. It works! If the current transaction isn't animated, the animation and completion are called immediately inline, so this code works whether the update is animated or not. And notably, a single animation running across SwiftUI views and UI views runs perfectly in sync. Now that we've discussed how to run animations in response to discrete actions, let's check out how these same APIs can be even more powerful when run in response to continuous gestures. Going back to our bead box, I'd like to drag a bead out of the box with a pan gesture and fling it towards the end of the bracelet. Here's some UIKit code that handles dragging a bead out of the bead box in response to a pan gesture. When the pan gesture changes, the center of the bead is updated based on the translation of the gesture. And when the gesture ends, the bead is sent to its final location. To animate this, we compute the initial velocity of the spring based on the current velocity of the bead, and we have to convert to a unit velocity by dividing by the distance the bead will travel from its current location to its final one. But wouldn't it be easier if we didn't have to do that? Yes! SwiftUI animations already have the ability to preserve velocity at the end of a gesture by merging together during the gesture, as shown with this equivalent SwiftUI code that achieves the same effect. No computation of an initial velocity when the gesture ends required. And now, this same technique can be applied when animating UI views, where the same SwiftUI animations can be passed to the new UIView animate method. As I drag across the screen, the gesture is continuously firing change events as my finger moves, and each of these events creates a new interactive spring animation, each new animation retargeting the last one. Then, when the gesture ends, a final non-interactive spring animation is created. This spring uses the velocity from the interactive springs to carry the animation forward with continuous velocity. Don't you just love continuous velocity? Like, it's the best! And that's it for animations and transitions. And now it's up to you. Adopt zoom transitions in places where you have a large cell to zoom from, enhancing visual continuity across your app. Zoom transitions are continuously interactive, so ensure your code is ready to handle a transition starting at any time. And start using SwiftUI animation to animate UIKit and AppKit views, especially in UI where maintaining continuous velocity is important. It could simplify your code a lot and make your animation feel much better. To learn more about the full suite of SwiftUI animations, my friend Kyle's video, Explore SwiftUI Animation, has everything you need. And for a deeper dive into Springs, check out my friend Jacob's video, Animate with Springs. And tell all your friends, or better yet, encode and share this knowledge in trendy bracelets.